Let's see what happens as we approach infinity or negative infinity, or as we approach vertical asymptotes. Okay, let's figure some of this stuff out. In the process of doing this, we're going to have a situation where we're going to have to factor a lot of things, often. Once we get the hang of some of the shortcuts, it won't become as necessary. So what I have done is for this entire set of notes, for the first three examples, I've entered them in the calculator already. The first one is activated, so let's just go to the graph and we're going to look at it. We realize we have a rational function, and this rational function has a vertical asymptote at positive 4, x equals positive 4, and it has a horizontal asymptote here, and here looks like it would be at y equals 2, and we can confirm that, unofficially confirm that. See that horizontal line at y equals 2? The graph will never cross that horizontal line, and if we were to type in whatever we want, we will never get an output of 2. Trust me. Okay, so back to the graph. When I said that we will have a horizontal asymptote of 2, that we do have a horizontal asymptote of 2, that means that we will never touch the 2. Never touch a y value of 2. So no matter what I type, I'll never get a 2 right here. So I could plug in a 1, I could plug in a 2, a 3, a 10, 1,000, a million. Now, I just told you that we'll never get a 2 right here, and we didn't. Now, eventually, a 2 will pop up because the calculator doesn't have the capacity to give all the decimals it needs to give. But it will never actually equal 2. So with all that in mind, let's begin this problem doing it the old-fashioned way, where we factor. There's a greatest common factor in the numerator, and it is 2. I hope you noticed that. It may not have been your first thought, but it is now. We also can factor the denominator, and that becomes x minus 4 and x plus 2. And we will continue by factoring the numerator a little bit more. That gives me x minus 3, x plus 2. And if you're noticing what I'm noticing, then you realize that this x plus 2 is going to cancel. And when x plus 2 cancels, I am left with 2 x minus 3 over x minus 4. Okay, let's proceed. I want to know what happens as x approaches 4 from the right. And I know, again, it's wrong to plug in a 4. You can't just plug a 4 straight in. It's wrong here, here, here. It's wrong everywhere. But if I go to my graph and I look and see what happens as x approaches 4, we are approaching positive infinity. So this thing is going up. You could say it doesn't exist. For the sake of this lesson, I'm going to say that it is positive infinity. As we approach 4 from the left, we're going down. And as it goes down, it's approaching negative infinity. The y value approaches negative infinity. Okay, now we're going to have x approaches negative 2 of our function. Notice that the f of x is here in all of these, just showing us which function we're dealing with. It's good to know. That way we don't lose track of it, particularly if we have more than one thing going on, more than one function in the problem. So x approaches negative 2. Well, I could not plug it in here or here, and at this point I canceled out the factor that kept me from plugging in a negative 2, and now we're ready to plug in a negative 2. So what I really have is 2 times, well, negative 2 minus 3 over negative 2 minus 4, and that gives me 5 times negative 5. Whoa, 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 I'm way ahead of myself. What in the world? Where'd that 5 come from? I was looking ahead at this 5 right here that was going to pop up, the negative 5. And I was mistaken. Anyway, we end up with positive 5/3. So there is a hole in this graph, and that hole is at negative 2, comma, positive 5/3. It's not going to show up on this graph right here. The calculator doesn't have the resolution for it. As x approaches infinity, okay, and this is where we get towards limits at infinity, and you can't count to infinity, you can't get to infinity, but you can make an estimate of what you would get as a y value if you could ever eventually reach the end of eternity, and that's not a thing, you can't. But if we were to go forever and ever and ever and ever and ever, let's go back to the table. If we go forever and ever to the right, plugging in an enormous number, and I'd get something ridiculously close to 2. We're approaching 2. I hope you've noticed that the horizontal asymptote is the limit at infinity. Okay, good to know. We're going to approach negative infinity. So instead of plugging in an enormously large number, let's plug in an enormously negative number. There we go. And we still get 2, and it makes sense. Now, this is one of those situations where the calculator didn't have the computational power to round it. It didn't have the computational power, so it just assumed the answer was 2. But it's not. It's 2.000000000 something. But if you look at the graph, you'll see that we are approaching a y value of 2, although we'll never actually touch it. Not exactly.